Let's look at this question here. We are identifying the metal. So they say a 0.5 grams sample of a pure metal carbonate reacts with 400 cubic centimeters of 0.25 mole per cubic decimeter hydrochloric acid. They say the reaction is represented by the balanced equation. So you have got two reactions. Remember, you have got two reactions. I said now, when you have two reactions, okay, this is what you need to do. You check what is repeating in the reactant that is repeating. So we've got HCl here, and we also have another HCl there. So this is what is our repeating substance, the reactant that is repeating. You check the reactant that is repeating. Now what you're going to do is to get the number of moles of HCl in reaction 1, and get the number of moles of HCl again in reaction number 2. Then you're going to subtract those number of moles. So you're going to get, you must get the number in reaction 1. In reaction 1, you must get the number of moles of HCl. Then in reaction 2, you must also get the number of moles. You must get the number of moles of HCl, because it is the one that is repeating itself there, meaning it is in excess, right? When it is repeating, it means it is in excess. Now, you must get this number of moles. In that way, you would have solved 80% of the questions, or 80% of the problem itself. Now, let's do it, and let's get into it. Right, I'm going to start by checking the information that I'm given. Okay, so I am given HCl. I'm given 400 cubic centimeters of HCl. I'm given 400 cubic centimeters of HCl. And I am given the concentration of HCl, 0.2 concentration. Right, now that is for HCl. Now for the other substance, this one, I'm only given 0.5 grams. Okay, but the aim, I must focus on the one that is appearing both sides. So now I'm going to do this. Check in the next information, we are given 0. KOH and this amount of KOH. So for KOH, you're given what? You're given concentration is equals to 0.6. Then the volume thereof of this KOH, V is equals to, given 150, but is in cubic centimeters. Cubic centimeters. Right. This one, it must be divided by 1,000 so that it is in cubic decimeter. Okay. Even the other volume here of this must be divided by 1,000. Okay, so in other words, it's 0.4 cubic decimeter, because volume must be measured in cubic decimeters. Then the other one, it should be 0.145. Sorry, 0.15. That should be 0.15. Okay, then with this information that I am given, remember the aim is to get the number of moles of HCl in reaction 2 and number of moles of HCl in reaction 1. You must get this number of moles. Once you get this number of moles, then you subtract them. That is when you are given the two reactions. Always you try to do that, okay? So let's see how. Now let me do calculations. It means that now, because in this case I am only given this number, the concentration and volume of that. I will use a ratio to get the number of moles of HCl. Since I'm given the friend here, I will use ratio to get the number of moles of HCl. That's how I will get the number of moles of HCl. But in reaction 1, let me start with calculation for reaction number 1. Right. So for reaction number 1, now we're going to say this is reaction 1. Okay, let me call it reaction 1. The aim is to get the number of moles of HCl. So I'm going to say concentration is equal to number of moles divided by volume. And the concentration that I have in reaction 1 is 0.2. The volume that I have is 0.4 over N. So you are going to get N is equals to 0. So you are getting those number of moles for HCl. Okay. Then now I go on to reaction number 2. So let me divide here. So for reaction number 2, in reaction number 2, right, I'm going to use the number of moles of KOH so that I can get the number of moles of HCl. So I have C is equals to N over V. The concentration is 0.6. Is equal to number of moles over volume, which is 0.15. And the number of moles is equals to, you substitute them, you get 0.09 mole. Okay, all right. So then now I got the number of moles. All right. Now what do I do now? I now want the number of moles of HCl. Okay, right. I am going to say now, to get the number of moles, the ratio of NaOH is to HCl is 1:1 according to reaction 1. Why do I say NaOH? Sorry, it is not NaOH, okay? What is the name? KOH. KAOH. It's KOH. Right. So now the ratio is, this is the ratio. The ratio of KOH is to HCl is 1:1. Is shown here. So the ratio here is 1 here, and this is 1 there. Coefficient is 1, coefficient is 1 there. Right. According to that ratio now, it means if I have 0.09 moles of KOH, then the number of, what are the number of moles of HCl? Right. So the number of moles of HCl will also be 0.09 mole, because the ratio is 1:1. Okay. Now this is the number of moles of HCl in reaction 2. In reaction 1, the number of moles of HCl. From reaction 1, we got this number of moles for HCl. That's reaction 1. In reaction 2, I first calculated the number of moles of KOH, then used the ratio of KOH to HCl to get the number of moles of HCl. So I got it to be this because the ratio was 1:1. So these are the number of moles for reaction number 2. Now let's look. Right. So this is what I got in summary. I got the number of HCl in the first reaction, the number of moles of HCl in the second reaction. Now, what do you do with these two number of moles? I'm going to subtract them. So can you see that HCl has got number of moles, has got two number of moles. Because HCl is a limiting, is an excess reactant, it will have initial number of moles, it will have reacted number of moles, and it will have unreacted number of moles, or the leftover number of moles. Right. And then I said here it will have reacted number of moles. It will have initial number of moles. Now, the initial number of moles of HCl is 0.08 mole. Then the unreacted number of moles is 0.09 mole. These, okay? Now, what you are going to do is you are going to subtract these two to get the number of moles that actually reacted. So because HCl has got three number of moles, 1, 2, 3. Amongst these three number of moles, the ones that you can use together with a ratio to get information about another substance is the reacted number of moles. You can use the reacted number of moles to get information about another substance. Remember, the aim here is to calculate, to identify metal X. Metal M. So I want to find metal M, which is my final step. Okay. What I'm going to do is to find the number of moles of this. I use the ratio of HCl to this. But which number of moles do I use in the ratio to get the number of moles of another substance? If you have an excess reactant, remember HCl is the excess reactant. It is in excess. That's why it's appearing more than once. Okay, it is an excess reactant. Now, because it is an excess reactant, okay, it will have initial, reacted, and unreacted. Now, the number of moles that we can use in a ratio to get information about another substance is the reacted number of moles. The ones that we got from reaction 1, they are called initial number of moles. Initial number of moles is the ones that we got from the reaction 1. We got this number of moles from reaction 1, this one. Okay, this one here, we got it from reaction 1. And this one, we got it from reaction 2. Those are the number of moles that are unreacted or are in excess. Now you have to subtract these two number of moles to get the reacted number of moles. So I say the number of moles reacted is equals to right. So we say initial minus final, and you get 0.1 more. Okay, now we say these are the ones that reacted, are the number of moles reacted. Okay, of course it seems like a big number, and when it seems like we're getting a negative number here, but it's just probably it's just their numbers, the choice of numbers here. Yeah, but everything that we explained is correct. Yeah, everything that we explained is correct. There's nothing wrong with everything that we did. Okay, so now I'm going to get the number of moles of this substance by using the ratio between HCl and this. Right. Remember, from the beginning, I couldn't, even if I had the number of moles, even if I had the number of moles of HCl, I couldn't use those number of moles in a ratio to get the number of moles of this. Why? Because this number of moles that I had were the initial number of moles. An initial number of moles cannot be used for an excess reactant. Initial number of moles cannot be used in a ratio to get information about another substance. You can only use the reacted number of moles in a ratio to get information about another substance. So that's why we didn't do a ratio to get number of moles of that using the initial number of moles. So now the ratio of this to HCl is 1:2. We can see the coefficient 1 there, the coefficient there is 2. Now HCl has got 0.01 more. Then what are the number of moles of N? So then the number of moles of N will be the same. They won't be the same because the ratio, because of you cross multiply here. So you cross multiply, you multiply here, and you multiply then. Going to get something like 2n is equals to 0.01. Then you divide by 2, you divide by 2. Then n is equals to 0.005. 0.05 mole of what? Of the metal carbonate. Now we got the number of moles of the metal carbonate. Okay. So the number of moles is 0.005 mole metal carbonate. Okay, so now I'm going to use the form, I'm going to calculate the molar mass of the metal carbonate. So I'm going to say number of moles is equals to mass over molar mass. Okay. Now, we say, right, number of moles is 0.005. The mass of the metal carbonate was 0.5 over the molar mass is equals to the mass of M plus the mass of the molar mass of carbon, which is 12, plus 3 oxygens, the molar mass. There. And this is 0.5 over M plus 60. 0.005. So if you cross multiply, you will have 0.005 M plus 0.3 is equals to 0.5. Then you take this to the other side. It becomes 0.2, 0.005 M. So you divide both sides by 0.05. If you divide by 0.005, divide by 0.005 there, you are going to get an answer of M equals to 40. And this is 40 grams per mole. Whenever you want to identify an element, you have to determine its molar mass. Okay, you must find the molar mass of that substance. Right, now in the periodic table, the one that has got molar mass of 40 is what? So we can see that the one that has got a molar mass of 40, it's calcium. That's calcium. Okay, that's calcium. So metal M is calcium.